What the heck? Why is it doing that? Hey kids, welcome to Robotics. I don't understand why they have a waiting room. Again, I went to the settings and changed the settings so that students do not have to wait in the waiting room, but for some ridiculous reason, they're putting you all in the waiting room and then I have to admit you. Very, very inconvenient.
Are you making sure that you click save settings afterwards? Actually, no. Zoom automatically saves. Never mind.
What it do, Shayna?
What's that? What did it do?
What it do?
It's like to come into our meeting. I used to have it where all you had to do was punch in the ID and the password, and then you got to come into the meeting. But right now, it's having you go into a waiting room, and then I have to like click admit for every kid who's in the waiting room, and it's like really inconvenient. I want students to just be able to join and not have to be shunted to some ridiculous waiting room. Maybe it's some weird security thing that they have that I can't undo, because I actually went to the settings and yeah, I pressed save. I mean, although actually with the Zoom settings, there is no save. You just do your settings and it automatically does it.
Guess do it on the website as well, or maybe specific meetings. I don't know.
Stupid thing. Yeah, maybe I changed the setting, but it didn't change it for this particular meeting. It only changes it for all subsequent meetings. I don't know. Stupid technology. So I'm having to admit each and every person who comes in, but it's all good to have you guys. We have 18 participants. Yay. 19 participants, including me, I see. All righty. Well, we got 19 of us out of about 50 or so, 55 or something. One person's waiting, Tom Chan. Okay, I'm gonna get started, and it's good to see you all. It's good to have you here in Zoom land. I'd like to spend a little time talking about the class, the schedule, what the district has decreed that we do. And then I'm actually going to teach you something. I'm going to teach you about the relationship between distance, velocity, and time. And then we're going to talk about rotational velocity and to talk about the relationship between rotational velocity, rotational displacement, and time. And then that's it. But first, the class itself. Are you guys aware that we'll be meeting every Tuesday and every Thursday? We'll be meeting every Tuesday and every Thursday. Right now, I'm doing it where I'll be meeting with my AP Physics students at 12:30, and then I'll be meeting with you guys at 1:30. We'll meet only from about 1:30 till 2. Our meetings will only be about a half hour. I will be teaching you, oh, just a second, one person's waiting. Okay, we'll be learning about gears and gear ratios and torque and things like that. But anyway, that's our schedule. So this coming Thursday, we're going to get together at 1:30, and I will email you the ID number and password so you can join our Zoom meeting. Before I go any further, is everybody receiving the emails through the school loop mail? Is that working out okay with you guys?
Yeah, that's Shane.
Okay.
Yes.
Group chat. Oh, how fun. Zoom group chat. That's so weird. last time I did Zoom, chat wasn't an option. So again, it's like things just change through no, experience of my own. Okay, so any questions or issues on our meeting schedule that we'll be meeting every Tuesday and Thursday at 1:30 tentatively, and I will send you a school loop email with the password and the ID number. You guys good with that?
Mr. Shane, I have another question.
Yes, Tom.
For like our worksheets, where are we gonna turn it in on Google Classroom?
Yes, you'll turn it in on Google Classroom.
Okay.
And so, and you're all in Google Classroom. So yeah, you'll just turn it into whatever period Google Classroom you're in.
Okay.
And it'll be an assignment. In this case, it'll be the Xerox that I just gave you. I haven't set it up in Google Classroom yet because we're not going to get done with the Xerox until Thursday. So I didn't feel any big hurry to try to get the Google Classroom set up just yet. Yes, that's where you'll turn it in. Any other questions or issues? Oh, I got Ethan waiting. Admit. Okay. Well then, kids, secondly, your grade. Right now, it's like everyone had completed everything you were supposed to do in the past. And so your grade would have been an A for everybody. But now they've got this rule saying whatever grade I give you on the 12-week grade, you cannot get lower than that. But I'm in this weird situation that I do want you to do this extra stuff, at least to the best of your ability. So I think what I'm going to end up doing, and this is going to be kind of weird, but I'm going to end up giving everyone a B for their 12-week grade. And then if you do any effort whatsoever, and here, let me admit everybody here. Okay, so I'm just, essentially what I'm going to do is assign everybody a B for the 12-week grade. And then if you do any effort whatsoever on what we're learning during our time of quarantine, then I'll just raise it to an A. And it's pretty much any effort at all. It's not a matter of how well you do on exams or anything, just proof that you're attending the Zoom sessions and trying to do that, you turn in something to Google Classroom, and then I can raise the B to an A. And I'm doing that just to encourage everybody to to do something involving this. And if someone has a good reason why they aren't, then just contact me personally, and we'll work it out. We'll hash it out there. Just one second. So does that make sense about your grade? Okay, so everyone's going to get a B on their 12-week grade, but remember, you do any effort at all, you show any engagement with our material during quarantine at all, and I can raise it to an A, but I've got to see something. Okay, and everything I just said, I'll put out in another school loop email after our meeting. All righty. Hey, does anyone have any other questions or issues?
No.
Okay. And we've got 30 of us together. That's good. That's a good amount of people.
Yo, Shayna, so
Yes, Cameron.
all the work is gonna be paperwork.
Cameron, I couldn't hear what you just said. Your audio broke up. That could be you or it could be me. I don't know which. Go ahead and repeat what you just said, Cameron. Oh, it's probably me. It says my internet connection. Go ahead.
I said, is all the work gonna be paperwork?
Yes. Yeah. Yeah, I can't have you guys doing any actual robotic stuff because we don't have access to any of the equipment. So yeah, it's just going to be a few Xeroxes. That's all, a few worksheets.
All right, for sure.
Sorry about my coughing. Any other questions or issues? Okay. Now, I don't know if I told anyone this. I don't know if I mentioned it, but I see a lot of people who are involved with BattleBots. And, BattleBots essentially is going to be put off till next year. So everyone who is involved with BattleBots, you know, unless you come by the school and, you know, on your own time, or unless you're a junior this year, it's going to be next year, which sucks. Sorry about coughing. I had a really bad head cold last week, I thought, but it's still around. Okay, then here's the last thing I'm going to ask you. From now on, when you sign on to the Zoom, please put your last name and first name, because I'm going to be taking roll. And the big way I take roll is to actually just take a picture of the screen with everybody's names on it, you know. That's my role. So if you call yourself Calculus God, then I don't actually know who that is. So here we go. I'm going to take roll now. Boop. All right. Then here we go. I'm going to start teaching you stuff. So here's the screen share. Boy, I really apologize about my coughing. Okay, right now you should see a screen share of the picture my iPad is taking. The iPad is taking a picture of this. Let me put this over a little bit. Of my paper, and this paper is going to be my whiteboard, and that's it. This is the high-tech thing I'm doing. I'm taking video of a piece of paper that I'm writing on. I could actually get a stylus and write directly on the iPad, but why do that when I can just do a piece of paper? Okay, so here we go. You guys learned this in Algebra 1. Speed equals distance over time. Also, this, I should tell you all this, all of my Zoom sessions are recorded. And so if a student misses a Zoom session, I will, what do you call, I'll be posting, I'm recording it, then I'll post it on YouTube, and I'll send you a link to that post. So you can actually watch this on YouTube if you want to, if you missed it the first time, or if you wanted to relive our Zoom session together, then it'll be on YouTube. Okay. So you know that if you're, let's say you go 12 meters, and the time it takes you to go 12 meters happens to be 20 seconds, then, you know, your robot takes 20 seconds to go 12 meters, then you know that this is going to be 0.6 meters per second. Is that okay with distance equals, speed equals distance over time? Then, looking at the Xerox that I sent you guys, you guys should all have a copy of this. And so look at the first problem. You want your robot to go 5 meters. Its speed is 2.2 meters per second. How many seconds must you give your robot current, your motor current? I may shut this down soon if I don't stop coughing. I'm so sorry. So again, you would go speed equals distance over time. But my speed is 2.2 meters per second. My distance is going to be 5 meters. And the time is what's unknown. And you must solve for the t, the time. And the most common way to solve for the t is to cross multiply, put a 1 under the 2.2, and then 2.2 times t equals 5 times 1. You have 2.2 t equals 5 times 1. That's the way you're going to have to do it. And then finally, your t is going to equal 5 over 2.2. That is, you'll have to divide both sides of the equation by 2.2.
Shayna,
Yes.
Audrey said you need to let him in.
Oh my gosh. Oh, there it is. Thank you. Yeah, I have to say again how very, very irritating it is that they're making my students go into a stupid waiting room and then I have to admit them. How inconvenient for me, you know? And like I said, I'm gonna look at the settings again. Okay, so anyway, and so my time ends up being 2.27 seconds. So what I'd like everyone to do now is try number 2. I like everyone right now, try number 2. You want your robot to go 7.3 meters. The speed's 4.1 meters per second. How many seconds do you have to give your robot current? Give it a try. Let's see if you guys get the right answer. And by the way, if you have a copy of this, the answer is on the bottom of the sheet. So I'd like everyone to do this problem. You should do it the same way. Okay. Hey, you guys done yet?
Yeah.
Okay. Yes, just a second. My wife wants my attention. Yes, Rob. Yeah, I've done it too. Okay, so here we go. We got speed equals distance over time again. But this time my speed is going to be 4.1 meters per second. My distance is going to be 7.3 meters, and my time is unknown. And again, I'm going to cross multiply, put a 1 under the 4.1, cross multiply. I got 4.1 times t equals 7.3. And so my t is going to equal 7.3 over 4.1, which is which is about 1.8 seconds. Is there any question or issue on this process?
No.
Oh, Nicholas Claunch is, yay. Go ahead. Okay, well then, you guys, I'm gonna trust that you guys can do problems 3 and 4 on your own, because now I'm gonna talk about rotational speed. Here, let me close this. Can I close this, Ron? Okay. Thanks, Ron. So now it's time to talk about rotational speed. And this is really the big thing that you need to understand with robots. Isn't speed equals distance over time, which is very important. It's rotational speed. So here we go. Rotational speed. There's other names for rotational speed. It's also called rotational velocity. It's also called angular velocity. And all of these is named by a Greek letter that looks like W, but actually we pronounce it omega. So this rotational speed, rotational velocity is called omega. And just as speed is equal to distance over time, rotational speed or angular velocity is equal to your rotational displacement. Rotational displacement over time. Now, rotational displacement has many measures. The angular displacement, that is not how far you went, but looking at my looking at my screen, my live video, it's not going to be how far the pen goes translationally. It's going to be how far this pen rotated. And so there actually ends up being two completely different and utterly independent modes of motion. There's translational motion and rotational motion, and they are completely independent of each other. One has no effect on the other. You know, if I threw a hammer to you and the hammer wasn't rotating, then all it had is translational motion. But if I threw a hammer to you and the hammer was spinning, then it would have both translational motion and rotational motion, and they would be independent of each other. So rotational displacement, looking back at the screen share, has several different measures. It can be degrees. I'm so sorry. It can be revolutions. It can also be radians. But here in a robotics land, in engineering land, we're going to deal almost exclusively with revolutions. We're going to talk, when we talk about angular velocity or rotational velocity, it's always going to be revolutions per second or revolutions per minute. Okay, so let's go ahead and do a really quick one. An object rotates 12 revolutions in 3 seconds. Find its rotational velocity. Omega. Hey, everyone, give that a try. What's the rotational velocity? By now, I'm hoping everybody is getting that it's 12 revolutions in 3 seconds or 4 revolutions per second. And that's the way we tend to write revolutions per second. We write it RPS. You ready to try another one? Good. Aman is nodding his head, and that's good enough for me. And here we go. A gear is rotating at 20 RPM. Now, I hope you understand that RPM is revolutions per minute. So it's 20 revolutions per minute. Okay? It rotates for 5 minutes. How many revolutions did it turn? And again, you can always start off with omega equals the rotational displacement. So good luck, everybody. Tell me, how many revolutions did this gear do if it's rotating 20 RPM and it does it for 5 minutes? When you're done, we're gonna try something. Let me see here, I'm gonna go, wait, okay, it's not really letting me do that. Someone's got a gas mask. Landon, you're funny. So what I'd like you to do is like put your hand up when you're done. You see on the bottom of the screen, you can choose like reactions and put your hand up when you're done. I'm gonna stop the screen share here so I can look at you guys. So like I've got Ethan done and Emma done, yay. You see, I've got it all here. Yeah, or yeah, good. Oh, you're actually putting your actual hand up, Ethan, that's good. Oh, but you also did the fake hand, the reaction. Here, I'm gonna do a reaction too. I'm gonna do the clapping. There we go. How do I turn that off? Does it just stop on its own or something?
After a while,
Yeah, it fades
After a while,
away.
it goes away.
It'll fade away.
There it is. It went away. Ah, that's weird. Okay, well, all righty. So, are you guys getting 100 as your answer?
Yeah.
Okay, I'm hoping so. Yeah, it's 100. 20 revolutions per minute for 5 minutes. That's going to be 100. Okay, good. The next thing I have to do is have you guys convert from angular velocity to linear velocity. But we've only got like 5 minutes left. And this actually, my purpose today was just to have us try this out, see if we could do Zoom. So really, all you're responsible for are the first 4 problems on that sheet. So that's it. And we're going to get together Thursday at 1:30 and do some more. I may actually do lessons that are more complete, video lessons, and I'll post them on YouTube and I'll get you the connection with them. But this is good enough for now. Are there any final questions or issues before we go?
Shayna, you said the first 4?
I'm sorry, yeah, just 1 through 4. Just the problems involving,
that was my question.
What's that?
Yeah, that was my question too. Is like only doing the 4 that
Just
involves.
do the first 4, yeah. Don't worry about the rest. We'll learn how to do them better, really well our next time together.
We don't have to print the paper, right? We can do it on a separate piece of paper.
Absolutely. You can just do it on
Okay.
a separate sheet of paper. And eventually, when you do all 14 problems that are on that Xerox, then you'll take a photo of your work and send it to Google Classroom.
Okay.
Good. And of course, there's no late. I mean, whenever you get it done is when you get it done. Whenever you send
So
it.
wait, Mr. Shane, I had a question.
Yes.
How do you know like what the rotational displacement is?
Well, you mean if they give you the speed and the time, then you end up just multiplying the rotational speed by the time, and that'll get you the rotational displacement.
Yeah, but like for the first example we did where an object rotates 12 revolutions in 3 seconds,
Yes.
like would the rotational displacement always be like 12 revolutions or like 40 degrees?
Yeah, you would have to put a piece of tape on the wheel and then count how many revolutions the wheel does.
Okay.
So you're just actually counting 1, 2, 3, 4, 5, like that.
Got it. Thank you.
Cool. Yeah. Anything else? Alrighty then. Hey kids, I'm gonna say goodbye and let's end our happy meeting. And I'll see you all again 1:30 next week.
Catch you, Shayna.
Yes.
Said I'll catch you.
Okay. Hey, bye-bye. I'm going to end it now. Wait, I'm not ending it. What's that? Are people saying goodbye? You're just saying goodbye, right? Okay. Bye-bye.
Bye, Shayna.
Bye-bye. End of meeting. End meeting for all.